Hello. Today we're going to look at an example of forming differential equations. So this example is aimed at about A-level mathematics students. Alright, so we're given that the rate of increase of a certain population P at a time t is directly proportional to the population P at a time t. So, given that p equals 4 when t equals 0 and p equals 8 when t equals 1, find p when t is equal to 3. So, I've highlighted the boundary conditions that will be very important for finding p when t equals 3. So, first of all, we're using a differential equation. It says the rate of increase of a certain population P at a time t is directly proportional to the population P. Okay, that should be obvious that we're using a differential equation. So therefore, we get dp by dt, the rate of change of P, and it says it's proportional to P. Okay, now, therefore, we're going to get that dp by dt, okay, is equal to k times p, where k is our constant. Okay, so we have got our differential equation, but we have got a lot more to do. We have to solve it first. So, if we multiply both sides by dt, okay, and then divide both sides by p, we get 1 over p multiplied by dp is equal to k dt. Alright, bring dt on that side, divide by p. So therefore, we integrate 1 over p dp is equal to the integral of k dt. Alright, this is a very nice, simple integral. This is the natural log of the modulus of p. So we do ln of p is equal to the integral of k with respect to t is just kt, k is a constant, and we add our constant of integration c. Okay? So, what have we got here? When p equals 4, so yeah, given that p equals 4 when t equals 0, hopefully we can use this equation to, along with our boundary conditions to get something. And that might be the constant of integration. Let's just see. So, therefore, p is 4. So we get the natural log of 4, okay? And t is 0, so k times 0 is 0. This is equal to 0 plus c. Therefore, we get our constant of integration, c is equal to the natural log of 4. Right, that's brilliant. Okay, so we've got our constant of integration. We can rewrite this equation here as the natural log of p plus kt, natural log of p equals kt plus constant of integration, which is the natural log of 4. Right, okay, right. We can bring the natural log of 4 onto the side, on this side of the equation, and we get the natural log of p minus the natural log of 4 is equal to kt. Okay, let's go on to the next side. And if you know your logarithmic rules, okay, you might be able to see that, I'll write it out again, the natural log of p minus the natural log of 4, what am I doing? Yes, is equal to kt. So, natural log of p minus the natural log of 4 is exactly the same as saying the natural log of p divided by 4. Okay, and that's equal to kt. Okay? Right, And I haven't got the other sheet, but if you remember, the other boundary condition we had is when t equals 1, p is equal to 8. Alright? So, when p is 8, t is 1, we get the natural log of 8 over 4 is equal to k, because t is 1. Okay? Therefore, it should be easy to see that k is equal to the natural log of 2. Okay, 8 divided by 4 is 2. K is the natural log of 2. Okay, so we've got our constant and we've got our constant of integration. Alright, so we have the natural log of p divided by 4 is equal to, so just using this top equation here, is equal to k, well k is the natural log of 2. Okay? And we multiply that by t. Alright? Now, another logarithmic rule. We should be able to see that we have the natural log of p over 4 is equal to the natural log of 2 to the power of t. Okay, if you have a constant multiplied by your logarithm, you just raise it to, so it becomes a exponent, natural log of 2 to the power of t. Okay? Again, if you're unsure on your logarithmic rules, you might want to recap on them, as they're very handy in many forms of mathematics. We're almost finished, so what we wanted to find is when t equals 3, what is p? Yeah? Because p is our only variable here, because we know t is 3. That's what we're given. So, yeah. So we can undo the natural logs by doing e, by putting e as our base. E to the power of this, e to the power of that. That undoes, I'm trying to speak here, that undoes the, is that a word? Undoes? Yeah, undoes a natural log, undoes the natural log. And so therefore we get p is equal to 4. Okay, we just bring the 4 on the other side. 4 multiplied by 2 cubed. Remember, we've undone the natural log, so we just get p divided by 4 equals 2 to the power of t. T is 3, so p equals 4 times 2 cubed. And therefore, we wanted to find in the first place when t equals 3, okay, when t equals 3, we can see that p is equal to 32. 4 times 2 cubed is 32. Alright, so I quite like that example. Yes, and in the future videos I'll do some harder examples on forming differential equations. I'll see you in the next video.